Well, thank you for coming to this presentation. My name is Larry Wickelius, and I work for Marvell. My role is I have responsibility for all of our partners, our ecosystem engagement, a lot of our software strategy, and I'll talk about how that fits into what we're doing. So some of you may or may not be familiar with the Marvell with two L's. That's us. And we are somewhat newer to the HPC and SC world. Some of you may know us from our previous location of Cavium. So Cavium is a company that was acquired by Marvell about 1.5 years ago. And I work for the ThunderX product line, and that's really the focus that I'll have today in talking to you. But first I want to give you a little bit of background on Marvell just briefly. So public company, been around since 1995, based in Santa Clara, out in the Bay in California. And we are approaching please come on in. We are approaching $3 billion in revenue, very heavy focus and investment in engineering. You see from the number of patents, a high percentage of that employee base is engineers, and we are a silicon company. So what we ship is silicon across the broad infrastructure. And I'll talk about some of the areas of our focus and technology areas and product lines. And we are based worldwide. So as I mentioned, we're based in Santa Clara, but large design center in Marlborough, Massachusetts, in Israel, Europe and Asia as well. So well positioned from that standpoint. Okay, so we are focused on infrastructure. Across effectively anything that you're going to think about as viable or functional or focused from an infrastructure standpoint in terms of security, networking, and storage. Historically, Marvell really started primarily in the storage area, so pretty much any drive that you have today is going to be based on IP from Marvell. Heavy investment in networking as well, both at the switching level, at the card level. We recently acquired a company called Aquantia that also does networking and expands into even the auto space. So a lot of that investment in that networking that spans from data center out to edge type devices. And then our compute space. And this is where I'll spend most of my time talking today about what we do in the compute space. But this is all silicon. So we're a silicon company, and that's our focus. We partner with different OEMs, different providers that take our IP or our silicon and bring out to the end market. So from a compute standpoint, please come on in. So from a compute standpoint, we have shipped many, many CPUs over the years. You see the range of product line here. Armada and Octeon are our lower end embedded and networking compute processors. If you followed Marvell at all, you hear a lot about the activity that we have in the 5G space. So we're really seen as a leader in that space with our Octeon line. ThunderX2 is our high-end compute processor that I'll spend most of my time talking about today. We're really known as the first company to bring high compute, high performance ARM architecture to this market. We've also demonstrated year over year and generation over generation expertise in multi-core, and we work very closely with ARM, and our compute processes are based on the ARM architecture. So if you're familiar with ARM, pretty much I'm going to bet that most of you have an ARM device on you, in your pocket, on your wrist, because most mobile and client devices are based on the ARM architecture. It's been fairly new in terms of bringing that architecture to the data center. So the way we work with ARM is an IP licensing company essentially. So we license that IP from ARM, and then we optimize it. We make microarchitecture extensions to optimize for our target use cases, and then we deliver the silicon. So that's the relationship as you think about and hear about ARM. Now, ARM has been tremendously successful over the years, and approaching their projections by the end of 21, 200 billion devices that they'll be in. So it is a well-established architecture, a very strong ecosystem in terms of design, in terms of software, in terms of fabs. So it's a very good partner for us, and that allows us to put our focus on areas of optimization and extension that we want to target. ARM is also very well known for performance efficiency. So as you look to larger and larger systems, especially in the high end of HPC, one of the challenges is cost of power, delivering power, and cooling. With the efficiency that ARM brings as an architecture, it's an advantage as you start to look at performance per power, performance per watt type metrics. And I'll talk a little bit more about that as well. ARM is well suited for a range of data center applications. Certainly big data and HPC is something we're focused on this week, but other areas extending into the cloud with some of the dense cores and scale out capabilities that you have with the ARM core. The Android use case is very interesting. So because of those client devices, those mobile devices that are out and based on the ARM architecture, what you run on your phone today, you can also run on the cloud in a hosted server. So think of gaming in the cloud. Think of CI, CD, testing, validation that you can move from a small device into a hosted device on an ARM server. So you can't really do that on an x86, or certainly not as efficiently, because now you have the same architecture, the same instruction set from that mobile device all the way up to the high end. Edge computing as well. I talked about our activities in the 5G market, and where you're seeing ARM continue to expand in things like NFV, in terms of 5G use cases, in terms of more of the, think of auto as I talked about before. So a lot of good fit from that architecture, and it really leveraging the broader ecosystem of software development and of hardware partners. So Marvell's product is ThunderX2. It is our ARM-based server. It's our second generation that we've brought to market from a server based on the ARM architecture. I won't go through all the details here, but a couple of things to highlight. As I mentioned, we license the ARM architecture. So things that we have done that are unique or different. We're the first ARM vendor that brought cache coherency or dual socket support to an ARM server. We support up to 4 threads per core with a fully out-of-order architecture. First time that's been done. One of the things that really has separated us from a performance standpoint is our memory architecture. So in ThunderX2, we support 8 DDR4 memory controllers. And what this really does is bring a lot of balance to the silicon. And a lot of our customers have publicly talked about benchmarks that were not compute bound, but actually they were memory bound. And with the increase in terms of number of memory channels, as well as our cache efficiency, we've seen significant wins in a number of benchmarks from a competitive standpoint, and really set ARM and demonstrated how ARM can deliver that kind of performance. You see the logo on the lower right-hand side, ARM server ready. So there's a standardization effort within all of the ARM vendors to ensure that even though we license that IP, we have the ability to optimize and change the IP, we're still consistent in terms of the standards that have been set, both from the instruction set itself, but also the implementation, so that as you think about operating systems or other software partners, they've got a common base to build on. And I would encourage you, if you have questions as I go along, feel free to raise your hand or stand up. So from a deployment standpoint, I'll talk about HPC in a bit, but I think also very important is work that we've done with some of the hyperscalers. So we actually just had another announcement related to our partnership with Microsoft a few weeks back. So Microsoft has deployed ThunderX2 within the Azure infrastructure, now deploying at scale. And so this is significant because this is actually the first time that Microsoft has taken a non-x86 architecture and deployed within Azure. So to do that has been a lot of heavy lifting in terms of all the porting of the Microsoft software, Microsoft OS, tool chain, applications. But now we've worked through all of that and deploying at scale. And it's really exciting for us. Also from a hardware standpoint, that's an OCP design, Open Compute. So Microsoft's been very public about the Project Olympus portion of OCP. This is a Project Olympus based motherboard that you see pictured here. is available for the specs, and all the details of that are available for download. So it's another, I think, proof point relative to the balance that we've implemented and the breadth of the type of applications that we can support. Now, specific within HPC, a couple that I've called out in the middle is Los Alamos. So this is a Cray-based platform that Los Alamos, as part of the Department of Energy in the United States, has deployed. And on the right-hand side is our Astra system at Sandia. This is an HPE Apollo 70 platform. It's actually the world's first ARM-based top 500 system, which is very exciting in terms of top 500, not only in HPL or the LinPack compute side, but also HPCG, which is really a metric around memory efficiency and performance. And with the most recent numbers, we're actually number 26 on that part of the top 500. So again, that balance that I talked about, that scale, I think also from a customer standpoint, a customer choice standpoint, the fact that we partner with a range of OEMs and that you have that choice in different designs. And in our booth, you'll see static samples from all of our OEM partners as well. See some of the other examples of our deployments here. Another one that we're really excited about and proud about and was recognized by the industry this week is Catalyst. So HPC Wire recognized this as the best collaboration in HPC this past year. So Catalyst, it consists of 3 sites in the UK, University of Leicester, University of Bristol, and Edinburgh. All HPE Apollo 70 systems running the SUSE Linux, Mellanox InfiniBand, and ThunderX2. And so each of those 3 sites has been collaborating and working together over the past year, targeting different application sets, different use cases. Leicester, for example, has done a lot around physics and astronomy. University of Bristol with Simon McIntosh Smith has done a lot of comparisons in terms of compiler performance and advances. You see some of the details in terms of the specifications here. You can see this system in the HPE booth this week as well. So this is another example of how we work both with our end users as well as our partners, continue to drive everything that we're doing to build up optimized solutions. And I think important, because we're standing in the SUSE booth, you see the SUSE logo, deploying SLES 12 at some sites and SLES 15 at other sites. We've done a lot relative to the overall software ecosystem. We've got well over 100 partners now that we work with and enable. The vast majority of these partners have many of our systems within their labs for test and validation. All of the Linux distributions today commercially support ThunderX2. We've got a wide array of compilers, tools, and basically pretty much anything that you would want to try from a software perspective, you're going to be able to take advantage of on our platform. You also see some interesting cloud examples. Verne Global is a partner in the UK that has hosted services on ThunderX2 if you need to do some remote testing or proving either as an ISV or an end user. Some of the edge devices and some of the edge use cases I touched on briefly before. Edge is interesting because depending upon the compute demand, it could require the capability of a ThunderX2, or it could demand more of an Octeon TX that is our lower end ARM processor. So the benefit that Marvell brings here is that breadth of offering and capability as you look at your different target requirements for various applications. One of the big headlines this week has been our partnership with NVIDIA. So if any of you had the privilege to see Jensen's keynote on Monday afternoon, he actually spent quite a bit of time talking about the work that we've been partnering with them on. NVIDIA originally announced at ISE 2019, just in June in Frankfurt, the intent to support the ARM architecture, bringing GPUs, CUDA, over 600 HPC and AI applications to the ARM architecture. And we've worked very actively and aggressively over the past few months to get to the point we are today with available releases. If you go to the NVIDIA booth, you'll see some of the references, including the PGI compiler, which will first be available now coming up in January. And our partnership with HPE on the Apollo 70. There is a configuration now that's in test for 2 GPUs per server. And then Jensen talked about their integrated appliance as well on Monday. So a lot of moving parts, and this really expands the touch points and the end user environments that we can deploy into now with this rich GPU support. So we've been working with SUSE really since the beginning. SUSE was one of the very early OS partners driving upstream enablement in the Linux kernel, in originally the OpenSUSE distribution. SUSE was actually the first commercial Linux vendor to commercially support ARM. So they've been really a lead partner for us and have really helped drive a lot of the early enablement. And now, as I talked about, they're a very valuable partner in that Catalyst deployment that has been well recognized. The OpenSUSE community engagement continues. This gives us a chance to push the envelope a little bit in terms of some of the other open source use cases, both at the high end as well as in the embedded side, as well as storage, which there's a number of different projects we're working with SUSE on there as well. Also an exciting demo that SUSE has on the other side of this wall. So a ThunderX2 workstation with an NVIDIA GPU, with SLES, and some interesting AI software. So I'll kind of tease you with that, and hopefully you can go check that out after the talk here. But another great example of where, because of the partnership, that demo came together. It was finalized Friday night, but it came together in just a few weeks. So again, the work that we've done together from that partnership really paid off. So I talked about a couple of these things already. We've had public press releases around our work with NVIDIA, the HPC Wire Award, another announcement that came out earlier today with another partner of ours, E4, which is an OEM partner that we have in Europe, based in Italy. I touched on some of the partner booths that we have here, and I would encourage you to go check out some of the other partners and what they're doing with us. There's also been a number of presentations. ARM had a user group on Monday where I would say about a half a dozen of our partners and end users presented on some of the applications, the performance analysis, the optimizations that they've been driving that are pretty exciting as well. So to do everything I've talked about requires investment. When I started, I mentioned that Cavium had been acquired by Marvell about a year and a half ago. So Marvell has continued to organically invest in the things that we're doing because silicon is not inexpensive, and it's not inexpensive to drive our partner community, but we are very committed to do that. And fortunately, we have some partners who have helped along the way in that investment. On the right-hand side, Los Alamos actually announced about a year ago their investment to help drive our roadmap, and I'll talk about that in a little bit, as well as ARM. I've talked a lot about how that partnership is key, but now ARM is also invested financially to ensure that we can continue to drive this market and continue to expand on what we've started on. So that's, I think, an important thing as an end user to know that this is a long-term viable, committed organization who's got a long track record of building silicon. So our overall roadmap, I'll just give you a little bit of a touch of this, and if you want to go deeper with us, I'd encourage you to come over to our booth and talk more. 349 is our booth number. So we originally came out in 2016 with the first ThunderX platform. Then we went to production on ThunderX2 in 16 nanometer in 2018. ThunderX3 will be our next offering. It will be in 7 nanometer, and it is tracking to 2020 next year. So a lot of the partners that we work with now, we're already enabling on ThunderX3. We're already upstream enabled for most of ThunderX3 capabilities, working with people like SUSE on the OS. So we just build off of that cadence that we've already established. ThunderX4 is a little further out. We're not saying a lot publicly about that, but because of that investment I talked about, we're actually able to have dual teams dual development in progress. We're able to shorten the cadence of our delivery of silicon and really drive everything that we're doing from a technical and innovation standpoint. Okay, so that's it from the prepared material. Any questions, comments that anybody might have?